My name is Jeremy Rauch. With me I have Dino Dizovi. Originally this was my talk, but Dino's here to lend support and be the color guy so he can make this talk a little bit more entertaining and fun. And you guys can be both entertained and informed, which is always a good goal to have for a talk. We're going to be talking about, is this mic working? I'm not loud enough? Okay, I'll talk louder then. What we're going to be talking about is what we call PDB, not to be confused with the Microsoft Debugger format of the same name, unfortunate same name, but the protocol debugger that we've developed as part of our services and our work doing protocol reverse engineering. For those of you who were at Tom and Dave's talk this morning, also in the same room, the same track, you saw some of the vulnerabilities that we've discovered as a result of some of our work, the classes of problems we see, and how we approach the problem. And PDB, as well as two other tools called Racket and Ramble, are the outcome of some of the things we've learned from doing these kinds of projects, and kind of represent some of the ideas we're kind of going forward with in making it easier for us to go and take arbitrary protocols and begin to reverse engineer them in a kind of coherent manner, in a way that doesn't keep me up really, really late at night and make my life hell, which is always my goal. Dino here is also going to be talking about the packet construction and protocol construction libraries we've developed that allow us to, again, take a protocol that we've reverse engineered, implement it, make something that modifies packets, or even write a client that allows us to fuzz it very easily, very quickly, and without having to have any crazy knowledge about everything at all aspects of the TCP and OSI stack, and things of that nature. So if that's not the talk you're expecting, FX's talk, which is probably pretty awesome, is going on right now. I appreciate everyone who came to this. I think it's cool stuff. Dino thinks I think it's cool stuff. Dino thinks it's cool stuff. So hopefully that you guys will find it informative as well, and kind of give you some insight as to what people who are doing this sort of stuff on a day-to-day basis are doing, as well as maybe get you guys interested enough in the tool that you go and download it and play with it a little bit and test it for me, because it's not entirely all that well tested, and make it better.
It's bleeding edge.
Bleeding edge.
And the blood is yours.
Calling it beta would be doing a disservice to the entire software industry. It is something that we're working on, and something we're using, and something we're developing as we go. I find it useful already. Depending on what you're doing, you may or may not see potential in it. Hopefully you see potential in it, but it may not do what you need to do right now. But it's growing, and we're going to continue to add to it, and it's going to be open source. As soon as this talk is over, I'm going to go and make it available. So you guys can do whatever you want with it. Recognizing, of course, that it is bleeding edge alpha, and be kind.
We use it. It's got scores of dead bug kills.
Sure.
So useful.
Somewhat.
Yeah.
So again, I'm Jeremy. For those of you, I've spoken here at Black Hat a number of times over the last, I guess, 9 years. I spoke at the first Black Hat about SNMP, kind of a protocol I was poking at back then, very crudely, very, very much not in the controlled, dissecting manner I do things now. And over the years, I've spoken about a number of different protocol things, a little bit dabbling in the vulnerability disclosure, some of the stuff I was involved with at Security Focus when I was there. Over the years, I've been involved a lot with IDS, and a large portion of IDS work, for good or for bad, and I won't get into whether or not I think it's the right way to do things, involves writing signatures to decode protocols and tell if there's something bad going on. So I've got a pretty good background in doing protocol reverse engineering. It's something that we do a lot at Matisano. I'll let Dino introduce himself.
I'm Dino. I like breaking stuff. I've done it for lots of people. And I like especially writing tools to break things better, because, staring at hex dumps gets boring pretty quickly.
Sure.
But.
Sure. And then other people involved with Matisano, again, Tom and Dave, you may have...
Sorry. It's good.
No problem. Okay, you guys hear me better now? Everyone's happy?
My feedback.
All right. Oh, yeah, feedback.
Yeah.
All right, so you guys probably met Tom and Dave this morning, where they talked about all sorts of vulnerabilities we found in internal applications, specifically agent-based things. those are things, the kinds of applications that are built with these oddball protocols. I have this pretty strong belief that in this day and age, everything should be done over SSL, because one of the things that's going to be an overriding theme throughout this talk is I am lazy, right? I do not like working hard, doing the same thing over and over again, and not making it an elegant solution. I hate doing rote things. I hate doing iterative things. I want to make it as easy as possible for me to reverse engineer a protocol and get into the interesting components of it. Which isn't to say that this is something I've been able to fully automate away. Aside from the fact that if I ever automate this away, I'm not going to tell any of you, because I'm going to continue to sell our services. But it's a very hard problem, and I'm very much of the belief that people are, we're really good at understanding certain types of problems. Looking at hex dumps, like Dino said, that's something we're not very good at, right?
Pretty good at it.
Yeah, I'm pretty good at it too. I mean, I've done it enough over the years. But being able to evaluate, like, okay, this is interesting thing. This is an interesting packet to look at. This is not an interesting packet to look at. Kind of using the things and kind of letting you be a little bit of the expert in control of the flow of what you're doing works really well. And we're going to look at how we're doing that. So Tom and Dave are also involved. We found a slew of vulnerabilities. We've left tons of internal applications and agent-based systems in our wake using tools like this. Tom also probably mentioned the black bag set of tools. Similar application layer, more so than protocol layer, but they all sort of tie together, and there's even plans to make some of these things a little bit better. This is a slide that it's what Matisano does, and I like talking, I like informing people, but there's always a purpose for these things, so I won't claim to be entirely altruistic.
If you like seeing us talk, you can have us talk in your very own company.
That's right, and we can come and break the things that you think are great, and make you feel not so good. Though the interesting thing I would like to mention is that while we're a consultancy, we're actually also a product company, and we actually do have our first product coming out called Clockwork. It says July, August. Obviously, that means more like August, and that'll be out real soon now. I got to tell you, we were all ready to ship that product for Black Hat, but I decided to spend all this time working on this talk. So I hope all of you appreciate the fact that I've now jeopardized the well-being of my company to be here to talk to you. So be nice to me. So we'll get away from that stuff, and we'll actually get into stuff that's interesting, and that's why you're here, and not for me to whore myself out or to whore Dino out. PDB is the topic at hand. So as I've mentioned, and as Dino mentioned, we spend a lot of time getting these projects from vendors where they want to deploy some strange application or some kind of black box, I don't know, let's say a SAN, on their network. And it runs all these protocols that are loosely defined with implementations that are closed, and no one really understands what they're doing or how they work. So we have companies who come to us and say, we're interested in using such and such vendor's agent-based protocol. It's 3 tiers. We want to know, is it secure? And we look at these things from the outset, and we look, and there are these oddball protocols that we don't obviously see anything in when we first glance at them. So what we end up having to do is look at those protocols, look at these hex dumps, and try to find some pattern out of chaos. Right? It's really the only way I can explain it. When you look at a hex dump, your eyes kind of go cross, and you don't really know what's going on, and you begin to pick out pieces, and this offset means this, and you kind of get an idea, and then you try to go and you try to write something in, I don't know, C, or using some tool set to go and make these packets, so you can go and write your own little really bad, really inexact, horribly wrong client, so that you can kind of start poking at the thing, and then you discover, I was wrong, that's not how the protocol works, and it was just dropping my packets all along.
Or there's gotchas like, if you were at Tom's talk, he mentioned that some vendor, basically they use base64 encoding for something, but they just rotated a couple characters in the decode table. Right? So basically it's base64 almost, so a little slightly different ordering. And vendors do either intentionally or unintentionally kind of tweak things a little bit, and so sometimes writing your own client from scratch is a huge pain in the butt. Sure. Whereas having something like this that basically lets you use an existing client, basically lets you just munge things, and you have a legitimate data stream that you can decompose, recompose, and just munge and corrupt and blow things up.
Right. One of the things that I always have a hard, maybe I'm alone on this one, but one of the things I always have a hard time doing when I'm writing my own clients for testing things is, especially when I'm crafting very raw packets at the IP level, is keeping states a royal pain in the neck. I don't really want to do that. I want to take existing tools. I want to be able to use Netcat or SoCat or whatever the cool tool to use these days is, and have it do whatever it does and do well, and then make little tweaks in line. And it's the kind of thing that a lot of people use plug proxies for. And we'll talk a little bit about what plug proxies do well and what they don't do so well as we move forward a little bit. But the thing to take away from reverse engineering protocol, that's a very manual operation, and it's one of those things that you can never tell how long it's going to take, right? You go and you look at an application, it could be something incredibly complex with hundreds of moving parts, and it's using something very basic as its protocol, right? It's using raw HTTP GETs, right? That's very easy to reverse engineer. You could also have a super, super simple application, something that allows you to, say, remotely control iTunes. It's just a random example. I don't get anything by that. But it could be a very complex protocol like Apple remote events, and maybe there's mysteries lurking in that protocol. But no one really knows what's going on, and it's a simple application, but it's a very complex protocol under the hood. So when you try to estimate, and when we try to estimate doing jobs for people, we never know what's going to happen beforehand. And when we end up having to go and write these protocols and write these tools all over again every single time, it takes forever, and it keeps me up late at night, and it makes me stressed. And I really don't like being stressed. So I had to have a way to make this more sane for me, and more sane for Dino and the rest of my coworkers, and hopefully it's something that other people can use too. One of the big things that I've discovered is that the tools we use to reverse engineer protocols, they're not protocol reverse engineering tools, right? Sniffers and the like were designed to be able to inspect traffic on the network, and they give you lots of great information. There's no doubt about that, right? Most of the sniffers that are out, Ethereal and TCP dump, are awesome, right? They give you tons and tons and tons of info. But they're not really designed to allow you to manipulate the protocol in subtle ways and send those packets on their way, at least not cleanly. And they're not meant to kind of interactively look at things and tweak bits here and see what happens and move around. So it makes it so that, they give you some useful info, and then there's other things I have to write, and then those things don't work together. And it's not perfect. But as a developer, one of the things that I always come back to, I love GDB. I think GDB is the greatest thing ever. If anybody here is a developer and doesn't know how to use GDB, I pity you. Printf debugging is the worst thing ever. ADB and other debuggers aren't really as good as GDB, but I'll give people the caveat that maybe debuggers are debuggers. Oh, the Windows debugger is awesome, but this isn't the Windows debugger. It's very much in the flavor of GDB, which I'm most familiar with and which I really, 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 really like. So you may see some similarities. I try to mold myself in something that works. Right?
Basically, if you know the syntax for GDB, you can sit down at PDB and be useful really quickly. If you know GDB and you know how network protocols work, either like PCAP, you can write like a TCP dump, command line that'll get you traffic you're interested in. You can set breakpoints, and you're on your way.
Sure. So the concept of basically, we're going to talk about this more. Sitting at one slide for too long makes me worried. So here's your current it's a tongue twister. Here's your current tool chain if you do reverse engineering of protocols. And there's obviously probably other things that people use, but this is the general kind of classes: sniffers, plug proxies, or more application-oriented proxies. Tools like libnet and libdnet. And then there's other tools that do the same things for Perl and for a couple other scripting languages. And then fuzzing frameworks that kind of help you do fuzzing on packets. My tool chain looks a little different. It's 3 items. We're going to be talking about them. The first one's called PDB. That's that packet debugger. The next one's called Racket. That's a Ruby-based packet construction framework. And then something called Ramble, which I named because, as I said in my talk description, it kind of just goes on and on and on and on, like a lot of people. And maybe I'm going to be going on in this talk. So I apologize for being my tool chain. But basically, it does the same iterative things over and over and over again. The things that, if you do manually, you're going to take forever and you're going to be really unhappy with the world. It kind of just does the same things over and over again. It does it really, really cleanly, really simply. So, rather than fuzzing 50 variables with 50 giant for loops and having code that's like 6 pages long to fuzz just one packet, it's a teeny little snippet of code that's really easy to understand, even if you're not a programmer.
Basically, the idea is if you can write the code to send one packet or do one transaction, you can turn that into a fuzz loop instantly for any number of variables, because writing nested loops is retarded. And
it also works really well with the toolchain that we've developed. I think that's its biggest its biggest upside.
Integration.
Integration, right?
Synergy.
It's all about making the world one in the Matisano way of life, and
we are all one, Matisano.
Right. All right. So it's all about synergy. So sniffers, why your tool chain sucks. Those of you who know me probably realize every other word out of my mouth is sucks, and it's a little inflammatory. It's not to say sniffers suck, right? Like I said, I really like sniffers. They do a really good job at telling you what's going on in your network, identifying traffic, and when they know about a protocol, they're fantastic. Matter of fact, if I ever have to reverse engineer a protocol that Ethereal knows about, aside from the fact that it means that I have a client who never did their homework and could have used Ethereal, it means that my job is 95% of the way done. I'm going to look at Ethereal. I'm going to look at their decode for that protocol. I'm going to steal it, and I might rewrite it in a language like Ruby that I prefer. I may actually probably take an opportunity to write it into Racket, but for the most part, my job is done there. But what sniffers don't do a terribly good job at is helping you reverse engineer or tweak and poke at protocols you don't know about, right? So when you're looking at reverse engineering a protocol, you've probably got a couple approaches. You can kind of look at different things in your hex dump and say, well, that looks like a character that seems to be incrementing. That looks like an integer that maybe is incrementing. And I actually have a module that I'm working on for PDB that does just those things automatically for you. It kind of says, yeah, I think that's an integer that's incrementing.
Like basically, you can say, this is a sequence number.
Yeah, we're going to look at that.
Yeah.
You're giving away the punchlines, Dina. We're going to look at the module that I'm working on from a conceptual perspective. It's definitely something that's not easy, and people have done crazy things to try to get it to work. Not mine to work, but to get the concept to work. And we'll talk about that a little bit more. But when you look at hex dumps, you're looking for variables that you can kind of pick out. You say, oh, that looks like a string. Maybe it's a counted string. And kind of do it that way. Otherwise, you're kind of, sometimes you end up with a plug proxy and you just randomly start changing values around, sort of do this blind, stupid fuzzing, which is kind of what probably is giving fuzzing its bad name in the past. When you just take a payload of crap and shove it into an application and see what happens, which really is, it's pretty useless. You might randomly stumble onto something, but it's not really useful fuzzing. So, Sniffer is really good if you want to randomly pick through things and say, that looks like this, that looks like this. They don't give you any way to check and verify those things because you have no way of manipulating those packets. Yeah, you can capture a PCAP dump, and then you can pull it into a TCP replay, let's say, and then you can have that, read the packet, and modify the packet and send it out. Oh, but it's stateful, so you'd have to go and do this and that and the other. It's tough, right? It's not really geared towards doing that. So I call sniffers are like the printf debug. I already mentioned printf debugging, but they're like the printf debugging of reverse engineering. You're just kind of like printing out crap and you're trying to figure out what's going on. And if things go wrong or you can't figure anything out, you don't have the power of a debugger to go and look at other things, coincidentally.
But wait, you do.
But wait,
no, wait longer.
Wait, well, you gotta have to wait until I get done making fun of your toolchain. Proxies, plug proxies, are actually really cool, right? I use a lot of plug proxies when I'm doing application layer stuff, which is pretty frequent, right? A lot of times we're discovering that that protocols move farther and farther up the OSI model or the TCP model, because I know people don't like OSI. They move farther and farther up the layers as time has passed. So you have all these applications that actually have a whole nother layer of protocol on top of them. You've got your SMTPs, your SSHs, your SNMPs. You pick one, right? And they're really just another protocol on top of UDP or TCP, right? They're not application. It's not like they're free-form data. They're actually application data, and they have form. And for things like that, plug proxies can work okay. You have the same limitations. You can kind of get free-form garbage. And one of the things that I don't like about plug proxies is the way people use them, right? They get some data into, they get a call on the sockets or some data. They write some code that modifies that data, and they shove it back out based on how they think something works. And it's a very iterative process, right? I try something, no, that doesn't happen. I try it again. I manually try to figure out the protocol. I write some more code to tweak out this parameter, send it again. It's just, I keep on having to stop and start and stop and start and bring the thing up and down. And I don't have a lot of patience, which again, anyone who knows me knows that's probably true. I don't have a lot of patience, and I don't have a lot of tolerance for that whole, I call it a compile cycle. It might be a script, but if I'm stopping and starting and stopping and starting, I lose focus, right? I want to be able to capture things as they come in, look at them, tweak something out immediately, send it along, see what happens. If it doesn't work, send another one, keep on doing that and sort of doing it interactively. And as I start learning more, automate those things so they can have them automatically happen in the background as a packet comes in or goes out, and then start tweaking out other parameters. So proxies, people tend to write them over and over and over again. They're not either they're highly generic and they're you're going to have to do a lot of work, or they're very specific, like a web proxy. Web testing proxies, those things are really cool.
Because you can,
there's a lot of functionality for web applications. They do that stuff very well, but they don't help you if you're reverse engineering some random oddball, IFCP protocol, as an example.
The problem is, getting sick of cutting and pasting your same basic,
Sure.
listen on a socket and connect out code basically, and just adding in the application-specific logic every time. And it's kind of a pain to have to basically be reversing the protocol, looking at hex dumps, figure out the framing, and then start cutting and pasting hex byte strings into your small proxy, and basically looking at it and be like, okay, this is maybe a length. Let's try putting a calculated length in there, and let's look like string. Let's try stretching the string out, make sure the length works, and make sure the exchange with the server still works. And this is a very tedious process going through, and we're basically taking the reusable components, like basically the proxying framework, taking the workflow, extracting that, so you can basically just focus on the protocol-specific elements of what you're looking at.
Sure, and making that iterative portion of trying to change variables and see what happens, something that you can do from a command line, from a PDB command line, and do commands interactively and do it that way rather than writing code over and over again. And I'm really bad at code reuse, so this is just my way of making everyone else use my code so I don't have to worry about it as much. Or at least these guys use my code.
I don't really use this code.
Yeah, I don't really use your code either. Other tool chains that people use, and I want to come up with a caveat that I don't dislike libnet and libdnet, because Mike's probably here and he's a very good friend of mine, and he's kind of big and scary, muscly and scary at least. Libnet and libdnet are really good at what they do, which is create raw packets and raw packet tools that are very fast. And by fast, I mean you can send things very quickly at things that more closely approach line speeds, the kinds of speeds that an actual computer can send things out. One of the things that our toolchain, as an example, doesn't do well is we don't send packets very fast, right? Scripting languages are slow, right? Libnet and libdnet, they can construct packets and send them out very, very, very quickly. To which I always make the point, okay, so what are you doing that needs to be so quick in raw packets, right? There's traffic generation tools and stuff like that. That might be a legitimate use of these types of things. And I'm not saying that those aren't things you should use them for, but for doing protocol reverse engineering and writing new protocols that you want to begin to poke at and dissect, they're intimidating tools to use, right? They're big, they're complicated, and you have to compile them. And that whole compile cycle, I hate it. It takes too long. And at the end of the day, writing in any scripting language is going to be quicker, and while it may not be as fast on the wire, you're going to get your job done faster, and it'll give you more time to write more tests and to find more bugs, which is more important.
Well, and give you an idea of how fast the tools are. We can spit out about 2 to 5 megabits of traffic pretty easily with bracket and ramble.
And that's 100% raw packet creation.
Yeah, that's
going
multiple layers of packet creation. Yeah, exactly.
But and then tools like libnet, they can keep up with probably your wire speeds and your processor. So we're not good at that. These things do that very well, but my question always is, what do you really need those things for when you're doing protocol reverse engineering? But they have awesome protocol depth, and that's one of the other things that libnet gives me is the ability to go and look at how a protocol is defined, steal it, and then use it for my tools so I can do what I need to do. So I really appreciate the work there. Makes my life easier. So the last component of your toolchain is usually some kind of fuzzing, I want to say framework, but unfortunately usually it's fuzzing in the sense of you write some code, you take your protocol definitions and protocol construction functions, and you write a bunch of for loops around them. And if you've got 10 variables you want to fuzz, you're writing 10 for loops so you get coverage over the variables you want. And that's really, really messy. It makes for code that's like reams and reams and reams of pages, when all you want to do is tweak out 4 variables and modify them and send them on their way and get some good coverage across those fields. It's a really big waste of time. And code like that, it's really easy to write for loops and really easy to do if statements. But I feel like the more conditionals and loops and all this other crap you're doing in your code, the more likely there's going to be bugs. And you want to spend time testing the protocol, not testing your code. So Most of the fuzzing frameworks out there, not a huge fan of, or most of the fuzzing directions. Now, one of the things I want to point out is I was talking to someone the other day who mentioned that they remember a few years ago at Black Hat how there was a spate of people doing talks about fuzzing, and people were very much down on that whole technique. Like fuzzing, that's just randomly throwing darts at things, seeing if something breaks. And that definitely was the approach a lot of people were taking a few years ago, and are still taking now, right? There's absolutely people who are throwing random garbage input into syscalls. My coworker Dave is an example of a person who throws random garbage into syscalls and finds stuff, no doubt. But it's kind of throwing that dart. The kind of fuzzing we're talking about is actually a very, very useful technique, right? Using targeted fuzzing allows you to identify fields you think might have boundary conditions, off by one errors, and all those kinds of things that you want to test, but you don't want to have to test manually every single time.
We prefer the technical terminology of either harpoon fishing or monkey with a gun.
Monkey with a gun is the one I prefer, because you want to be a little more precise than just randomly shooting around and hoping you hit something, right? I mean, obviously with certain protocols and certain OSs and syscalls, if you hit a wide enough swath with enough garbage, you're going to hit something. But we want to be able to do things where we're feeling we're getting good coverage on the protocols we're looking at, and we can honestly tell a customer, hey, yeah, that we checked that out. That looks like it's good. Here are the problems. We covered 95% of the protocol. Okay, so here are the things that you should want, which just coincidentally are the things that we're providing. Pure coincidence, though. Proxy, like a plug proxy, which works well, right? It allows you to intercept real traffic coming from a real client and modify it, but with interactive type functionality, right? Look at stuff, manipulate stuff, and begin to examine the protocol without having to program, right? Plug proxies, you want to do it this offset, and I want to look for this type of packet and do the following things, and it's not so easy to do, and that's code that you're going to have to write and mistakes you're going to make, and it's always annoying when you think you're looking for a certain thing and you discover you were wrong about the protocol, and your half a day of testing has to be thrown out because you were wrong. You just never saw it because your program was working, but it wasn't working correctly. And the other thing I don't want to do is I don't want to have a whole new way of thinking. I'm sick and tired of programming and testing paradigms in security. Like every year there's a new one, and everyone has a new idea on how everyone should do things. And I just want to use a debugger, right? I want things to work the way my debugger works and to feel the same way, so that when I sit down at it, I'm not thinking to myself, now, what's the programming paradigm that I forgot last week that I need to remember again this week so I can do this project? I want it to be familiar. Obviously, it's not going to be a one-for-one matchup ever, and probably a large portion of that blame is on me right now. But I want it to be something that I can sit down at and, I'll be up to speed again in a few minutes because I'm constantly in GDB, I'm constantly in a debugger, and this way I'm constantly in a debugger when I'm working on network stuff as well. Other things, extensible and reusable, right? I want to work smart, I'll work hard, but I really prefer to work smart and hard than stupid and really, really hard, because I like sleeping and I like having a social life. And I would rather take the knowledge and the things I've learned and build off of them so that I can get my work done quicker and get it done more succinctly and do a better job without being up all night or waking up in the middle of the night in the cold sweats thinking, I hope I didn't miss something in that protocol. Craft packets without thinking too hard also, and do fuzzing against those packets without having to modify things or rewrite them or go crazy and do stuff that I don't want to do. Okay, my tool chain. And I say my tool chain, it's really our tool chain. And we'll say half of it's really Dino's tool chain. So our tool chain rocks. I am lazy. Dino, not as much.
I'm pretty lazy.
So I wanted this to be something to help me be lazy so I can do less work. I want to do iterative protocol debugging. I want to tweak things as I go and not think too hard about things and modify, basically inspect like a sniffer and modify like a proxy, right? But do it all in one package and do it really simply. And then, after that, take the stuff that Dino wrote and that I merely kind of work with and
integrate it.
Synergize it. And make it so that I can construct and manipulate packets in a clean, coherent manner using a language that's general purpose, right? Having to use some oddball language to create packets seems like a real nuisance. Having to use C and fill out structures, and if I don't mem set this, God knows what gets set and all that stuff, it's kind of annoying too. So I wanted to use a scripting language that people like and know. I used Ruby because Dino used Ruby, and Dino likes Ruby, and I think Ruby's pretty cool. I think a lot of languages are cool. I think Python's cool. I think Perl's cool. I think whatever hammer you want to use, that's cool. We happen to use Ruby in this. PDB is actually technically scripting language agnostic in that you can plug any scripting language into PDB. PDB is written in C, but it kind of works with anything.
Well,
but Racket isn't.
One thing we should check is, is Ruby well enough known that it's not an oddball language at this point?
Yeah, like
People know Ruby.
Do any of you guys
It's
use
Python for New Millennium. Metasploit's in
Yeah.
it now. You can use it. It's cool.
all the cool kids are doing it?
Yeah.
You should too. It's what is it? Ruby's well, I guess Ruby's old, but Ruby's 2006 is Python.
Yeah.
So
Ruby on Rails powers Web 20.
it's cool. It's
Important
cool
stuff.
stuff. Yes.
All right.
Anyways, enough Dino plugging Ruby. It's got a clean, consistent interface. That's one of the biggest problems I have with other packet construction libraries is that their interface today and their interface tomorrow, those could be two different things at any given moment. And then depending on how I might construct one type of packet in one way, another type of packet another way, and there's no consistency. Ruby, because it's object oriented, I can force you to do it the same way over and over again. And it also means it's kind of like C# and .NET, which I'm not an expert at by any stretch. One of the nice things about them is that they have a consistent way of doing things. So if you understand one paradigm, well, I'm sure someone will disagree with me and hate me for saying, but if there's one way you do things, you're probably going to do the same thing. You're going to implement the same sort of things in other classes. There's some kind of consistency in how you do things, and that makes things easier for people to learn and use. And then it's really quick to debug, right? It's scripting. You run it, and if it breaks, you tweak something and you run it again. So your code gets working very, very quickly. Unlike C, where like I said, I think I love GDB because I'm always writing crappy code that I have to go debug. So this way I've got a nice scripting language that gives me nice errors and has a debugger that's pretty, it works.
Interesting.
So Ramble is the fuzzing framework. You take the stuff you write in Racket and you automate it and do all sorts of cool things with that. It is specific to Racket. Is that really true, Dino?
Nah, not so much. It's
Okay.
it's actually a general purpose sort of fuzzing iteration and fuzz generation. Basically, one of the main ideas is there's a lot of good fuzzing frameworks out there, but all they give you is ints, chars, and maybe like a long string and some format strings. But when you want to do actually precision surgical fuzzing, you want it to look like, you want something that looks at least like an email address. And so basically it's hierarchical, so you can basically build, it uses, the thing I love about Ruby, it's all like, it has all the cool programming language geek stuff like generators. So you can basically nest fuzz generators and say an email address is a string at a string dot a string.
Well, we'll actually see an example of it.
We'll actually see an example of that. So there's some of the ideas that extend to whatever you're doing.
So we're going to talk about the specific implementations of each of these tools. And then we're going to look at samples, sample screenshot of PDB, some sample code for Racket and Ramble. Then we're going to do a quick demo of PDB. I say quick because, like I said, this is a bleeding edge tool, and I know it works, and I know it works, and I don't know it doesn't work. So we're going to go and we're going to go look at SSH and look at the SSH handshake and the kinds of things you can see and what you can do at a pretty simple level. As an example for a kind of a toy decode, right? Decoding SSH, I mean, it's a good protocol. It's not something I've ever had to be paid to do. And one of the things that kind of gets in my way a lot is that we do a lot of work that I can't go and make public. Anybody who was at Dave and Tom's talk where they were like, and this one vendor had this problem, and this other vendor, it's the same sort of problem. But it's a good example. You can see a protocol you can single step through, look at different values, edit the packet and send it on its merry way. And then we'll talk about some other stuff. So PDB is, I call it GDB meets Spike proxy. Makes testing, manipulating stateful protocols at any level easy, and it's interactive, or it's not interactive, because it actually can do other stuff that's automated actions, sort of like GDB macros. Kind of, sort of. Meh, sure, close enough. So a protocol debugger allows you to set breakpoints, right? Now in code, you can set conditional breakpoints based on certain variables being at certain values, or you can set it for a specific line. The analog with a packet, or at least the analog I've sort of adopted, is that breakpoints for packets are BPF rules, right? It's the easiest way for me to describe what I want to see in a packet very quickly. BPF, a lot of people think of it in terms of, you can say, well, I want to say host blah and port this. BPF is actually it's like a full-blown programming language to some degree. It actually has the ability to do looking at specific offsets within packets and evaluating them compared to other ones and subtract them and say if it's greater than this than that, then do this. So it's a very powerful way to describe how to evaluate what packets you want to see. And it's also, for the most part, an easy way to say, let's say I only want to see packets that have payloads in them because I really don't care about the TCP handshake. It's an easy way to go into the TCP dump man page, take a single line, tweak it out a little bit, dump it, and only see payload of packets, right? And then take some action based on having seen that. And we'll look at that in a second. You can single step through.
Or just use TCP dump, craft your filter so you can capture the packets that you want, and you just cut and paste the command line, throw it in there, and you have your breakpoint command line.
I'm all about stealing stuff, or I'm all about borrowing stuff from good projects. And I am not going to write another filtering language. I think that'd be a humongous mistake.
Unless it's in Ruby.
Unless it's it's a humongous mistake, and I like using BPF. I know BPF. I'm pretty good at it, and I'm really good at reading the man page. So it was a good way to go about setting breakpoints and saying, I want to see this packet when this happens. Don't bother me otherwise. You can single step through packets, meaning I can look very quickly at a hex dump of a packet, say, I don't care about that packet. Continue, until I see something that's interesting to me. And one of the things I said was that I feel people are really good at identifying what they're interested in, but we're not so good at programming how to say to something programmatically, don't be interested in this, care about this, because it's not always obvious what we want to see. But when we look at something very quickly, at least I can do it, and I know Dino can do it. I can pretty quickly say, I want to see this packet, I want to start poking at that packet, especially if it's part of a stream, right, or part of a session-oriented protocol. Hit enter a few times, I see a packet that looks interesting, I take my hand off the enter key, and I start tweaking at that point, right? You can do things like modify the data then, or drop the packet, or set a watch point, or disassemble the packet if you already have some stuff you've done to define the protocol, and to start dumping out the contents of that. Breakpoints are not just a way to get into the debugger, though. You also can associate actions with breakpoints, and we'll look a little bit at that. But basically what you can do is you can call out to an external module. And that's the way we integrate in with the racket stuff, where basically PDB, which is written in C, and we'll talk about the implementation in a second, will get an action in, and it says, well, this packet matches this action, or this rule. I'm going to call out to the Ruby action with a script, and let that script do whatever it wants in that packet. And when it's done, it'll pass it back to me. I do not care what he did, as long as he didn't, free the packet, because then I'd be pissed off. But basically then send out the packet or make some additional tweaks to it and go from there. But you're able to kind of create these macros, or these, you can create both commands and automated things that just takes away all the work you want to do over and over and over again, and just lets you do things that are important to you. And again, you can call it external modules in any language you like, so long as you like C and Ruby. It's not a limitation of PDB, it's a limitation of my time. And writing a Perl module like the Ruby module, or a Python module like the Ruby, it's really simple. And what you'd actually do is you take the Ruby module and you'd replace all the Ruby calls with the appropriate Python calls. Pretty straightforward, pretty simple. Okay, Protocal Debugger is not a substitute for intelligence. It's not an automated testing tool. I'm not, at this point, automatically splitting open packets and identifying fields and doing crazy stuff like that, but I'm working on it. It's also not a good way to do fuzzing or iterative testing, which is what Dino stuff is good for. And PDB is a crap name, because again, I didn't realize I collided to Microsoft. It's the problem with being a Unix guy, or mostly a Unix guy. These guys within my company who are much more Microsoft guys kind of informed me a little after the fact that PDB is in fact a Microsoft debugger database format and all that stuff. So I'm going to come up with a new name, or I might not, because I'm going to keep on calling it PDB no matter what. So it's not the best of names, and if any of you have a better name, I'll be glad to take it, or borrow it, or whatever. Okay, so the way PDB works, implementation-wise, and this is not important stuff for using it. I just like telling people how I wrote it, because again, I love showing places where I've taken existing projects and grafted them together and made something that's much greater than the sum of its parts. So PDB and the heavy lifting around PDB, as far as I'm concerned, which probably isn't entirely true, but the complex stuff, the asynchronous packet handling and eventing and all that stuff, is built around Neil Provost's libevent package. which if any of you do any asynchronous programming or want to write plug proxies or whatever, you come out of this talk thinking I'm crazy. If there's nothing else, you should take a look at libevent, because if you're writing your own select loops and all that fun stuff in C, it's not really worth doing. Libevent's really, really cool. It works really well. It's got events around, obviously file descriptor events, timer events. I don't know. There's other stuff in there. It's a wealth of asynchronous programming libraries. So the other thing it's easy to use, so I didn't have to think too much. And it should make porting pretty easy, in that libevent works on more platforms than I've probably ever been on. So it should make taking it to any modern Unix pretty straightforward. The hard part is the fact that we use divert sockets right now. Divert sockets work on things that are IPF based. So OS 10 works great. FreeBSD I've had up and running, though I can't swear that it actually works on FreeBSD right now. Again, bleeding edge, working on it really hard, not doing other stuff I should have been doing so I could be here to talk to you guys. OS 10 works great. FreeBSD, meh. Other things, not so well. One of the things I have to do is identify the way to do the equivalent of a divert for especially a Linux. While I'd like to tell everyone they should go get a Mac right away because they're awesome, which is true, I realize that I'm already pushing enough of an agenda with my tool than to encourage everyone to go get Macs, and the problems that have been identified along with that by Dino today at least. So right now, if you're on a BSD-based system that supports IPF, you're in luck. If you're not, you're out of luck. And I will work on that very, very hard. And especially if you tell me I really, really want this tool, but I'm on Linux, more of you who tell me that, the more likely I am to actually go and boot my Linux machine and do something about it. So the cool thing about divert sockets, though, that I really, really like, is I don't have to do any thinking or any configuration to get traffic. I don't have to do anything programmatically other than set up a divert rule in IPF and then open up a divert socket, and my data is there, and I'm able to associate to these asynchronous events and do whatever I want with them, which is awesome. I'm probably going to get working for other platforms using PCAP and some ARP trickery, where I basically say, all right, so any traffic that's coming to this MAC address that doesn't really exist, I'll pick up off the wire and forward it along and change the MAC address and sort of act as a man in the middle for that stuff. Which, if any of you were lucky enough to be in our training class last year, you probably saw us do some of that stuff with, you were in our training class last year. How's it going? We did a lot of stuff using cooperative firewalls, where if you were able to set the MAC address, static MAC address of where you wanted to get to, you could more or less create a proxy without having to do any real work on your client or even point it somewhere abnormal. You can do the same thing with PDB. I'm going to look into doing that real soon now and get it to work that way. So PDB works like GDB. You start up a program under GDB, you get presented with the GDB prompt. PDB, you get the PDB prompt, and it allows you to set the breakpoints up front, set up what actions you want to handle, load modules, which contain new commands and new actions and all that stuff. There's some default actions. PDB itself is very skeletal, right? It supports some very basic commands that are built directly into the PDB, the two of which are a debugger, which is the debugger, and hex dump, which I just happen to stick into the binary. Everything else is done using modules, and they all kind of self-register themselves to extend the command set. Originally, when I wrote PDB several months ago, just as a tool for me, I didn't really know what I wanted, so I had this giant if-else statement and all this nested stuff. And every time I looked at it, I would get disheartened and a little depressed because I didn't know what was going on. So it totally got gutted. Everything's based on function pointers and callbacks. So when you want to extend the debugger, you introduce a new shared object into it, and that shared, or not, you could compile it right in if you wanted to. And all it does is you call an init function on it. The init function goes and registers any commands, any variables it wants to allow setting and stuff of that nature automatically, and it just works, right? So PDB, very stupid. The modules themselves have the smarts in them. So the syntax in a nutshell, you've got module commands. Module commands load modules, right? You do a module add, then you give it an alias, right? All these commands work with aliasing, so you don't have to remember numbers or the name of a shared object or a bundle on OS X. And then the name of the object in that case and any arguments to pass to it. The same thing applies to all the commands, rule commands, print commands, edit commands. Everything sort of works using the same parser where all I'm doing is registering handlers for different verbs, and it kind of works appropriately. There's lots of aliasing commands is really straightforward because all you do is you register it twice, same function pointer, 2 different names, and that way, because I've used this tool with like 12 different iterations, and I think commands are different than they should be, I just have all of them be commands, so I don't have to remember anything. And then syntax can be extended by modules. As I said, PDB itself, not so smart. Modules can process packets. We're going to look at a sample module in 2 seconds. Maybe I'll even just go on to it. Oh, I'm sure you guys can't read that. This is a very sample scalable module. There's basically 2 important functions there. There's an init function, right? When you load a module, init gets called automatically. And these are all with shared objects in DLOpen, which you're all probably familiar with. It's the way you do shared objects in Unix. It's just an easy way to introduce functionality into programs that you don't have to recompile them. You can extend them. So what happens is, under the hood, it's loading a module. It says this module needs to have a certain set of functions that I can identify using DLSim, and then it automatically calls init. In this case, the init function goes and registers a command table, which is the command handler. It registers a new command called sshDump, which points to the function that's very loosely defined up above. Loosely meaning not really defined correctly. And then there's a function called onPacket, which says when if I'm registered as an action for a packet coming in, the packet will get passed to this function, and I can call whatever I want and do whatever I want with it. Right. So some of the modules we've done and are working on, and I think some of these are pretty damn cool, if I must say so myself, because I probably do. One of the ones we have is actually the ability to find interesting magic numbers and files and things of that type within packet payloads. It's really easy to do, right? Things have files have headers that allow you to tell what type they are. So we're able to identify things like gzip components, zlib components, JPEGs, if you want to do that for some reason. More interestingly, though, ASN1 and things like PKCS keys, right? So if I have a protocol where I think there's a key exchange happening, but I'm not really sure how it's happening or where it is, I would actually be able to tell you at this offset, I think there's a PKCS key, and here's what I think it is. It's an offshoot of other tools we wrote independently, and kind of said, well, we can integrate this into our PDB, and we can reuse this code and make it so that we don't have to go and try to reapply the same code 100 times in 100 different ways. Other things we can do, we can detect TLS. One thing that's really, really annoying is when vendors decide they're going to use TLS, but they modify it. So before they switch into TLS mode, they do a whole bunch of crap up front, and then poof, suddenly they're in TLS, and it breaks STunnel. Right? STunnel is a cool tool, and I really like it, but I really, really hate when things break it. So this allows us to do things like be able to say, oh, I know the offset for this beginning at TLS is this, and then in theory, we're actually not doing this right now. It's, again, part of another tool we wrote. You'd be able then to call out to STunnel and have it handle the connection instead, and transparently take it over and let you know it is TLS, it starts here. There's all this stuff before then. Maybe you want to look at that because maybe that's interesting stuff to look at. And then you don't waste your time trying to reverse engineer TLS, which, while we've done bits and pieces of, is not a lot of fun and probably not as fruitful as looking at stuff that people have implemented on their own. The module that I'm really hot and heavy for and that I'm working on is field width and type identification, right? Like I said, I'm really lazy and I hate reading hex dumps. So what I want to do is I want to have the ability to programmatically have something that goes in there and makes some heuristic-based guesses as to what things are at any given offset, right? Using some basic heuristics, right? As I mentioned, people have tried to use genetic algorithms or have actually successfully used genetic algorithms for this kind of stuff. It's really, really complicated, and it works pretty well most of the time. Sometimes, kind of, but it's really heavyweight, and it requires a lot of sample data, and
like Sidewinder that's being presented here requires access to the remote host, so you can load a debugger on there and basically, get to know, basically identify the code coverage that you're getting, and that's the fitness function to your genetic algorithm. If you don't have that access, you're basically just, slamming against a server that all you have is basically its replies to your packets. You can't use a technique like that. So using something like this that basically just goes on, just analysis of packet dumps.
Right, it's basically a simple little scoring system where it starts looking at single bytes, shorts, longs, and then looking at things it thinks are strings. Pretty straightforward, pretty simple. Well, hey, it's pretty straightforward, not so simple. and getting the heuristics rights and all that stuff is a little difficult. But it's a cool way to kind of begin to identify those things and give you a clue. Like, go check out what this is, and there's all sorts of cool methods to do it. And Tom's actually got some cooler ideas than I had using entropy for that stuff. And I know people have talked, I think, this morning about using some other techniques to identify strings and code blobs and all that kind of fun stuff. And then the Racket module is the really cool module, which Dino is going to talk about. Here's a quick look at PDB. We're going to look at it in a second. Actually, run it. Yeah. So the next thing we're going to look at is Racket, which is the packet construction library. And I'll turn it over to Dino.
Okay, well, so we're running short on time, so I'm going to speed up a little bit, so excuse me if I'm speaking a little quickly. So like we mentioned before, Racket is basically our packet construction library using Ruby. Basically, some of the design goals, like, a lot of Ruby, software written in Ruby is basically don't repeat yourself. I don't want to move my fingers, more than is absolutely necessary. So basically, the less typing, the better. The less typing, the less bugs. And so basically, we have a lot of shortcuts. Like, I don't want to have to write getters and setters for all the packet fields. I want to write software that'll do it for me. All I do is I teach it how to deconstruct a packet and the names of the fields, and it does everything for me, and I'm good to go. I also don't want to have to teach it about encapsulated payloads. Basically, it knows that a TCP packet can be inside an IP packet, and basically knows how to fix everything up, fix the links, and basically propagate field accesses through that. So let's actually get to what everyone's waiting for, more code on the screen. So hopefully it's a little more readable than Jeremy's screenshots. Yeah. But basically, it's pretty simple to see what we're doing here. If you've ever done any scripting language, you can read this. And this is just, simple bit of code to send, a million basically land-like packets, like the old land denial of service attack. And basically what we do is we create an IP packet, set the fields that we want. The module knows how to set sane defaults. So if we don't really care what a field is, it's going to have a value that makes sense. And if we set it, if we set a field that is, that other fields are dependent on, it'll automatically patch itself up before it gets sent out. For example, down at the bottom, when we say send it, we basically say, okay, IP packet, pack yourself. And it knows at this point that its payload is another TCP packet, and that's a class that has the same interface. So it says, okay, you pack yourself. It does a checksum, it grabs the links, it patches everything up. So basically, we are sending the packets that we want as soon as possible. And sometimes
I'm about to say Ruby's object-oriented design makes it real. I mean, people have their differences and their issues with object-oriented languages, but for stuff like this, it's actually really nice because you can make it so that everyone inherits from the same base class, everyone knows about everyone else, and you don't have to have a whole lot of thinking involved in what order I need to pack things and all that fun stuff. Everyone just kind of works together, and you say send, and it knows, well, I need to do the following things for everybody underneath me, and everyone knows about everyone who's underneath them and above them, and we're talking about packets.
A lot of magic mojo, and we also do cool stuff like automatic packet decoding. So this is actually really important. We're using it in PDB, where you can basically say, I have a byte buffer, and all I know from PCAP is that it's a Ethernet packet. And you say, Ethernet, new Ethernet packet, pass it the buffer, and basically there are tables that know that, if ether type equals this, it's an IP packet, and so the decoding cascades all the way down, and you have one packet object that it knows all the embedded types. And one thing this code example doesn't actually show is where we're setting fields in the TCP object, like TCP.th_export. We could just call that into the IP packet as well. We could say, the variable we call IP, we could say IP.th_export equals 22, and basically it knows, oh, this is not my field, this goes to TCP, send it down.
Yeah, it basically makes it so that you don't have to sit there deconstructing packets, which, it just seems pretty obvious that you might as well automate that away. And again, this is also built on kind of a registration, everyone kind of knows what they know and lets everyone else know what they know system, so that when you want to extend it, you write your module, and it needs to know to register in one place, and then it suddenly works with everything else, right? So there's no giant switch statements that say if it's this, then do this.
And give an example of how basically, you don't have to write field accessors. Basically, when you're defining a class, we have a structure called a pack struct, and all you do is you give it a pack string. If you've used, Perl or Python, they have similar functions called pack. You basically give it a string of characters that encode the width of fields, and all I'm doing is I'm saying, these are all the fields, and these are all their names, and I'm done. And basically, we have everything in Ruby is all duck typed and magic OO fastness that I can instantly use those below. I can say, self.ipv, and it'll basically route it through Magic Mojo to get to the right place and set the field. And I can query the object and say, what are the packet fields you have? So I can have automated fuzzing, because I have, like, if I want to fuzz an IP packet, all I do is say, give me the fields you support, give me a list of them, and we use Ramble to just basically, I know the field, I know the widths, and we instantly are fuzzing all the way over it.
So really quickly, Ramble allows you to fuzz without having to do any work. Let's just go look at the sample. I think that's actually probably the best way to look at it.
Yeah.
Sticky.
Yeah. Yep. We have some cool stuff with that, or basically where
let me phrase that. We've implemented a very, very large percentage of the IP. There's a lot of IPv6 options, a ridiculous number, as a matter of fact. We've implemented, I think, most of them at this point. TCP, so let's see, IP, IPv6, TCP, ICMP, ICMPv6, IKE, ISACAM, most of IPsec, stuff up into other protocols that are not part of the base stack type things, but they do support all those really hairy.
The fun thing like extension headers, next headers, IP options. We have fun stuff for all that.
Yeah.
This is the way I roll. This is how I fuzz. Basically, like I said, you basically just define the types. And basically, the cool thing about Ruby is you have things called blocks. And these are just code snippets that basically call with variables. So what I do is I create a new block, and I say, here are some default, I have 4 variables, here are the default values, here are the types, and those are basically creating generators for them, and I give it basically a function, a lambda if you're down with that. And basically, it runs this block of code for every iteration, every possible value of those types, of those fuzz variables, each one. So it iterates, it starts with the first one, goes to exhaust all its values. Once it's done, it uses its default value and starts iterating the second variable. So basically, if you can send one packet, you can send a million, and you fuzz over whatever you need. We have basically a test framework. This is unit testing for packets. Basically, you define a test case, define some methods. Basically, what our framework does is it'll basically go through a directory full of classes like these, and just run all the tests in a really quick fashion. It'll do a check for a heartbeat of the host between every test, and it'll say, 1,000 tests run, everything worked fine, or after test 9, after test something else, host went down. Actually, I think the output message right now is a very offensive message, but we'll change that.
It's a good way if you're someone who's implementing a custom protocol and you want to be able to test yourselves for meeting certain criteria. It's a good way to do regression testing, right? Writing a bunch of test classes and running them after the fact, that's cool stuff. Always glad to reuse my test code.
Do a very fast demo.
Very fast. Okay, ultra fast demo. So this is PDB itself. What's on screen right now is the pdb.conf file. As I've mentioned, one thing to keep in mind about me, I'm a horrible typist. So I try to make as much of this demo not me typing, as much as me showing you the stuff that's going on as possible. So this is the configuration file that gets loaded automatically at startup for PDB. And it's basically doing a couple simple things, right? It's loading a couple modules. It's loading the racket module, right, which is Dino's Ruby module. It's adding a couple of rules. And if you know TCP dump, that may or may not look familiar to you. They're fairly complex rules, or they look fairly complex, but all they're really doing is demonstrating that I can read the man page and steal code, or steal stuff out of man pages. All that basically says is, in the first case, it says if the destination port's 21, and there's a payload. And the second one says if it's port 22, either direction, and there's a payload, I want to see those packets. I don't want to see bare acts. I don't want to see sins. I don't want to see resets or fins or any of that stuff, right? Because from a protocol reverse engineering perspective, who cares, right? I know those things are going on. I know how TCP works. Most of the time, you're not going to be testing the base protocols, the TCP IPs of the world. When you get to, it's actually a lot of fun. It's really cool to do. And it's definitely something, I'm sorry, I talked. And I'm adding then rule actions, where I'm basically saying, for SSH, I want you to automatically add the action that you're going to hex dump the packet as soon as it comes in, and then when you see a packet, dump me to the debugger. Okay?
Send us a packet.
Yes, same as a, what?
Send us a packet.
Send us a packet. Okay, so here these are just commands I entered ahead of time so that I didn't have to type them. The first thing lists the rules. You can see the SSH rule and the actions associated with it. You can see the list of modules that are currently loaded and the kinds of things that they've introduced. And you can see the commands. Again, there's like 2 modules loaded right now. The list of commands that are available. And the really simple one that we're going to demonstrate is called SSH dump, which just gives us some very, very basic toy-like information about the header of an SSH packet as an example. So set it going. It's now in motion. It's waiting for a breakpoint, which is data on the SSH port. So all we have to do is basically kick off an SSH there, and it'll trap to a packet. And looking at that packet, we can see parts of the SSH. If I run SSH dump itself, it goes and gives me information about the banner that came back from, in this case, the server. And then you can single step through it and see additional packets as they come in, which is really cool. And one of the things that PDB has a big problem with, and I don't have a solution to it, but I'm trying to think of one, is that it tends to kick off exponential backoff because you're trapping packets. And what happens is you get retransmission stuff, and then it gets all hairy, and then I have to send packets again before I can see the information I really want to see, which allows me to look at more interesting fields within SSH. I can see, in this case, the negotiation that's going on for SSH. I can see all the ciphers that are being offered by the server. So it allows you to do things like that interactively. I can skip through to packets I'm interested in. I can modify a packet. I can say edit offset 100, set that to a bunch of A's. And then if I hex dump that packet out, somewhere in there, I don't know where.
It's off the screen.
It's probably up there somewhere.
Yeah.
We're really slow. Somewhere on there, it edited the packet. Maybe I'll edit it 200 or something. Just so you believe me, it actually works. It allows you to, yeah. It's one of the, remember what I said about what I said about hex dumps and them being really, really hard to work with? It's the truth, God's honest truth.
It's not there.
It is. It's a bunch of A's, not 41s. So.
Oh wait.
There it is.
Lowercase.
All right. So there.
Oh, you're right.
There's a bunch of A's, so it worked. So you edited the packet, and then if you went and hit enter,
I should send it out.
It's stuck in this retransmit loop, so it's not going to. But it actually sends it out. Whatever I tweak it out to be, I can affect any field I want with a more full SSH decode. SSH actually has a framing protocol as well. It actually has little headers that tell you about what's in there and the type of messages it is. You're able to take that, and then you can automatically say, well, if it's this kind of packet, then do these kinds of operations, and so on and so forth.
Once you use this to figure out how the protocol works, you start automating that into basically Ruby script, and basically you can take action, add commands to basically tweak the protocol out.
Okay, so rather than this talk being about me telling you about all the cool stuff we wrote that you can't have, because that's kind of bogus, we're releasing this tool. It's going to be available on our blog as soon as I get done talking and talking to people afterwards. I'm going to do a blog post. The code will be up there, matisano.com/blog. What was that?
Oh no, we're confusing.
See,
it's log.
It's not a blog. It's a log. So it is in fact /log, not /blog.
We're not bloggers. We're loggers.
That's right. So it's our security blog. So it has the tool on. It will have the tool on there. You're going to get exactly what's on. You're going to get exactly what's in the PDB directory of my hard drive, and you can do whatever you want with it. Right? It's entirely open source. Think of it as being I have to write a license for it, but it'll be a Berkeley 3 clause. Do what you want. I'd love it if people gave me feedback and used it and all that stuff. But also check out our blog because we talk about lots of cool things. So if you've read it already, you know how great we are. And
keep your eye on that space. We'll be making updates with my code in it.
Yeah.
My code is totally broken right now because I was like, I thought I could get everything like rehashed, but no.
So one other things I'm going to do, Tom's got this little black bag toolkit, which he probably mentioned in his talk. There's going to be a PDB style interface to one of his tools there, so you can have a debugger for streams-based stuff, which I think is also really cool. Racket's going to have more protocols and better Ruby code. And Ramble, I have no idea what we do with, but we'll probably do stuff. If you guys play with the tools and like them, fantastic. Again, let me know. I like positive feedback. I'll take negative feedback too. I feel pretty good about myself. I think I can take some criticism. Just remember, it's free and you get what you pay for. Other things, if you're just using the tools successfully or unsuccessfully, that's cool too. I just like knowing that someone's getting some use out of something I'm doing, other than me and Dino and the rest of my coworkers.
We also accept O-Day submissions if you find bugs that you like with it.
Sure. Yeah, if you find anything,
send them to us.
I'm gonna add that to the license somewhere. If you find anything cool, you have to tell us. So the moral of the story at the end of the day, with PDB, reverse engineering still sucks. It's still really hard, but it's a little less sucky for us now in that we're able to kind of build off what we've done and what we've learned and made our lives a little bit easier. And as more and more people use the tool, you'll make it better for all of us. So, it's kind of a symbiotic thing there. So questions, as I said, are your way of letting us know you listened. So if anyone has any questions, from what I gather, the best way to do it is you can come forward, and we'll give you the mic if you want to do it that way. And you can ask the question, and then I can, come up with some kind of answer, hopefully. Or Dino can.
I think we're out of time.
Or if we're out of time, feel free to come up.
We still have time? 4:30? Till 4:30?
8 minutes? Okay, cool.
Oh, wow. I thought we were...
Anybody has any questions and wants to come up here to ask them? If they want to ask them before the room, cool. If you don't want to ask them before the room, you want to ask them directly to us, that's cool too.
If you want everyone to know how smart you are, you can ask them. We'll run the microphone over to you. Right. If you just want to know the answer, you can come up here.
Exactly. If you want to prove that you're better than us, now's your chance.
Cool.
Thanks.
Thanks.
And again, check out the blog in about, let's say, I'll give myself a little time to eat some lunch, about 2 hours, maybe 3 hours, and it will be up there, and go at it.
Read our blog.
But don't file security vulnerabilities, because I'm not listening.